Good afternoon, everyone. Thanks so much for joining us in our weekly departmental colloquium. Delighted to present Dr. Benjamin Pitt. Ben comes to us by way of University of Chicago, where he did his PhD with Daniel Santo, also interfacing with a group of Susan Golden-Mehta. Doctoral studies were on the spatial experience, spatial reasoning as it affects the perception of time and of number. And he's now here doing a postdoc with Stephen Piantadosi. Did I say that correctly?
Yeah.
He just moved here only to discover that soon he'll be shipped down to the Bolivian Amazon, hopefully returning.
Hopefully.
How long are you going for?
3 weeks.
3 weeks.
Yeah.
Yeah.
So they say. Yeah.
What's the other season there? Ben will be talking to us about metaphorical mappings of time and number, how cultures shape cognitive universals. Please go ahead.
Thanks a lot, Dor. Thanks for having me. It's nice to be here. As Dor said, this is my dissertation work that I did with Daniel Casasanto, looking at how some of our most basic concepts, in this case our concepts of time and number, vary as a function of culture, and what those cultural differences can tell us about how our experiences shape some of the fundamental aspects of our minds. So the big question here, I forgot let me get my laser pointer ready, which I forgot. What's a talk without a laser pointer?
What was your date gesture?
Yeah, I might. Okay, let's see if that works. It does. Excellent. Okay, so the big question here is, how do people reason about abstract ideas, right? So what are abstract ideas? Well, for example, similarity, time, number, emotional valence. How do we reason about these things? Part of the answer is space. Not this kind of space, not outer space, but this kind of space, up, down, right, left. So the first evidence of this, the fact that we think about these non-spatial things spatially, comes from the way we talk, right? As Benjamin Whorf famously says, we can hardly describe the simplest non-spatial situation without constant resort to spatial metaphors. And it's true, right? So for all of these examples, we talk about these things using spatial language. So we talk about a close resemblance, a long time, a big number, the right answer, right? These are all spatial terms that we use to describe non-spatial conceptual domains. Okay, so these metaphors in language are very prevalent and they're super interesting, but they don't tell the whole story. It turns out that there's also spatial metaphors in our minds that don't show up anywhere in language. And I'm going to talk about two such metaphors, two widely studied such metaphors, metaphors for time and number. So it turns out that we think about time and number in terms of left-right space, even though we don't talk about it that way, right? Nobody says that events later in time are to the right of earlier events. We don't say that bigger numbers are to the right of smaller numbers, right? And yet we think about both time and number in exactly that way. And when we do, we get what's called the mental timeline and the mental number line, the MTL and the MNL. I'll try to say them out, but you'll probably catch me saying the acronyms. And at least in Western cultures, both of these mappings tend to go from left to right, right? So later events are on the right and bigger numbers are associated with the right. So how do we know, first of all? How do we know that people have these mappings in their minds, right? Well, let's start with evidence that the MTL, the mental timeline, exists. Well, there's a lot of sources of evidence that the mental timeline exists. It shows up in the way people gesture spontaneously during speech. They tend to gesture, Westerners at least, tend to gesture to the right for later events and to the left when talking about earlier events. It shows up in explicit spatialization tasks. So if you have people spatialize objects like plates that represent breakfast, lunch, and dinner, Westerners will tend to put breakfast on the left and dinner on the right. And it shows up in more implicit tasks, like reaction time tasks, where people are faster to press a button that represents later events in time using their right hand, but faster to press a left-sided button for events that correspond to earlier times. Okay, so the MTL exists. What about the MNL? How do we know the mental number line exists? There's similarly a few sources of evidence for the mental number line, but by far the most prominent one, and the one that's most relevant to this talk, is the snark effect. This is what is the snark effect? Well, don't worry about the acronym. The SNA stands for Spatial Numeric Associations. What a snark effect is basically a reaction time effect in which people are faster to press a button on the left for smaller numbers, but faster to press a button on the right for larger numbers, right? When you have them classify those numbers in almost any way. This is what's important here is to note that a sort of normal Western snark effect looks like this negative slope. What this negative slope shows is just the pattern of reaction times that I described. So people are faster to classify 9 with their right hand, but faster to classify 1 with their left hand, right? So the slope of this regression line gives us a nice continuous index of people's mental number lines. Does that make sense? Cool. Okay, so as I've hinted, whereas the mental timeline and mental number line tend to go rightward in Western cultures, that's not a universal feature of these mappings, right? There are other cultures where one or both of these mappings go the other way. The question is why, right? What aspects of people's experience, cultural experience, is determining the way that they're spatializing time and the way they're spatializing number? Right, how does culture shape concepts of time and number? That's our question here. So I'm certainly not the first person to ask this. Many people have looked at both of these mappings for several decades, and there's a very clear consensus in the literature. The answer to this question, if you look at the literature, is it's about reading and writing, right? That the way that people read and write text determines both the direction of their mental timeline and the direction of their mental number line across cultures. Okay. But actually what I'll show you now is that the existing evidence for this claim is not good, right? Whereas there's very good evidence that supports this link, a link between reading and writing and the mental timeline, there's very poor evidence supporting the claim that reading and writing shaped the mental number line. Okay, so let's take a quick look at that evidence. So the first question, right, is the correlational one. So if the mental timeline is shaped by reading and writing, then the direction in which people read and write should correlate with people's mental timelines across cultures. And it does, right? So if you look at cultures where people read and write text from right to left, like in Arabic and Hebrew, what you find is evidence of the mental timeline from all of these sources, but reversed, right? So it reverses in the way people gesture, it reverses in the way that people explicitly spatialize time, and people show the reverse pattern of reaction times. Okay, so the answer here is yes, reading direction at least co-varies with the direction of the mental timeline across cultures. Okay, so that's the correlational question. What about the causal question, right? The causal question is, can reading experience change the MTL, right? The correlation, I'm glad we've got that correlation. What we want to know is, what's the active ingredient? How can we interpret this correlation? So to do that, you need to basically manipulate orthography, right? Manipulate the way people are reading or writing, independent of other cultural and linguistic variables that correlate with reading and writing. So this is what Casasanto and Bettini did. They had participants read text either normally written from left to right on the screen or mirror reversed from right to left, and then had participants classify those sentences as referring to points either earlier or later in time, right? Using one of two response keys, one on the left, one on the right. Right, and what you find is that for people who read normally from left to right, you find the normal pattern of response times where people are faster to press the left button for the past and faster to press the right button for the future, right? What happens for the people who spent just a few minutes reading the other way? You get a complete reversal, right? So these people, at least transiently, show completely reversed mental timelines after just a few minutes of reading reversed text. Okay, so that's strong evidence that yes, the way in which you read and write text can change the direction of the mental timeline. Okay. So just to review the evidence for this link, it's very good and is supported by both correlational and causal experiments. What about this other link? Can reading and writing, in addition to shaping the mental timeline, is there evidence that it shapes the mental number line? Well, we'll ask the same two questions. So the first one is, do they co-vary, right? So if you look at the cultures in which the MNL has been studied, cultures that read or write from right to left, here's what you find briefly. In Palestinians who read text from right to left, you find what you'd expect, right? A right to left mental number line. In Lebanese, arguably similar, but in at least two other cultures that read text from right to left, you find normal mental number lines, normal, meaning Western mental number lines that go from left to right. Right, so here we have no clear covariation between the direction of the MNL and the way people read and write. Okay, so the answer here is no. What about the causal question? Can reading experience change the MNL? This has been attempted once before, actually, in the sort of seminal snark effect paper. Dehaene and colleagues showed French participants, French number words, that were written either normally or mirror reversed, and had them classify them in the sort of normal snark task, expecting that the way in which the number words were written would would sort of affect or maybe even reverse people's mental number lines. What did they find? That it didn't, right? That actually, despite the way people read the text, people showed normal snark effects. They showed snark effects that looked like normal French snarks. So the answer here again is no, right? This is a null effect of reading and writing on people's mental number lines. Okay, so whereas we have good evidence for this link, right? We have actually no clear covariation to support this link and no causal evidence to support that link. And yet, what Dehaene and colleagues concluded from that paper is that the particular direction of the spatial numerical association, the MNL, seems to be determined by the direction of writing, right? Despite these null findings. And in fact, they're not the only ones to make this claim. There are many dozens of researchers in the 25 years since this paper came out have made similar claims, saying things like the snark-like associations are shaped and modified by the direction of reading. Reading activity is indeed causally involved in the mapping of numbers onto space. The snark effect is modulated by reading direction. Others talk about the crucial role of writing direction in priming the direction of the association of time and number with space. In a recent paper, the effect of writing direction in affecting the spatial numerical association has been shown unambiguously. Okay, so people are very convinced that this is the case, right? That reading and writing shapes the mental number line, as well as the mental timeline, despite this pattern in the data that I argue doesn't support it. So you might be asking, okay, well, is that really the only game in town? This hypothesis that reading and writing is the cause of cultural variation in the MNL? Well, the answer is basically yes, right? So there have been some proposals, some modifications to the original reading and writing hypothesis in the 25 years since it was proposed. For example, some people sort of expand the set of experiences that might shape the MNL to include spatially directional scanning of visual materials, so not just reading and writing, but other types of visual scanning. And others expand that set even further to include all spatially oriented activities. Anything that goes in a direction shapes these mappings. Okay. But what's important about the variations in this proposal is they all share a set of basic implications, right? Which is that the MTL and MNL should be changed by the same set of experiences, right? Including reading and writing. and they should be changed in the same direction. So all of those variations make these central claims. And what I'm gonna refer to this sort of collection of similar proposals as the common cause hypothesis, right? So reading, writing, scanning serve as a common cause for both of these mappings. Okay, so right, and according to the common cause hypothesis, time and number are spatialized in the mind by a common set of experiences. Straightforward. Yeah.
Are you okay with questions?
Sure. Yeah. Please.
So this is mostly clarification because I know in Hebrew the text is doing the right stuff, but if there's a number like 789,
yeah,
it's going the other way. That wouldn't explain the lack of effect with the French mirror result. But has anyone thought that maybe there was something different about the Israelis and Iranians, like either the participants just were correlated with greater literacy or more math exposure, or do the other cultures actually reverse the numbers in their text? I'm not sure if everyone just goes 789 or if there are some people who do 987.
Right, exactly. Yeah. So, so there is a proposal. Right. So you're making an important distinction, right? Which is a distinction between the way people read and write per se, right, in general, and the way people read and write numbers. And often those are the same, like in English, and sometimes they're not, like in Hebrew. They go in opposite directions. And so some people have proposed, oh, well, maybe in addition to the direction in which people read and write text, the way in which they read and write numbers also matters, right? So that idea is out there. It has so far been treated as an additional factor, in addition to reading and writing normal text, right? And later on in the talk, I'll come to a study that isolates those things and looks specifically at the spatialization of sort of numbers on the page, as it were. Yeah, but good question. Other questions about this proposal? Feel free to interrupt as needed. Okay, so we've got our sort of first proposal here, the common cause hypothesis. That's very popular despite this pattern of evidence, right? So why these findings, right? Why this pattern in the data? Why would reading, writing, scanning affect the mental timeline but not affect the mental number line? Well, to answer that question, I want to talk about mental metaphors, which I started to talk about earlier when I was talking about metaphors without language, right? Or metaphors that aren't present in language. So what's a mental metaphor? A mental metaphor is a point-to-point mapping between two analog continuums in different conceptual domains. So what does that mean? I'll unpack that a little bit. In a mental metaphor, you have what's called the target domain, which is typically the more abstract domain. In this case, that's time and or numbers. And then you have a source domain, which is a different conceptual domain that you use to represent the target domain. So in this case, the source domain that we're talking about is lateral space. And by mapping the source domain onto the target domain, you get a mental metaphor, or two mental metaphors in this case, the mental timeline and the mental number line. So what's useful about this, I think, is that it allows us to reframe this question, how does culture shape concepts of time and number, as this more general question, how does culture shape source-target mappings, right? Regardless of what the particular source and target domain are. Okay, does that make sense? Questions about that? So my answer to that question comes in the form of a principle, which I call the correlations and experience principle, or the core principle for short, which says simply, source and target domains are mapped in the mind according to the way they're correlated in experience, right? So we'll unpack that. In the case of spatial domains, when you're spatializing abstract stuff, this principle simplifies slightly to the way abstract conceptual domains, like time and number, are spatialized in our minds should reflect the way they're spatialized in our experience, right? So this makes two very straightforward predictions about what kinds of experiences should shape the mental timeline and which kinds of experiences should shape the mental number line. Namely, the MTL should be shaped by experiences that spatialize time, and the MNL should be shaped by experiences that spatialize number. Right? So now we've got our two proposals here, our two contrasting proposals, and now what I'll do is walk you through three experiments that contrast the predictions of these proposals. Okay, so experiment 1, can reading experience shape the MTL and the MNL the way that everybody thinks that it does? Okay, so, well, if we want to answer this question, we should ask, well, what does reading spatialize, right? Does reading spatialize time? The answer is yes, right? When you read in English, you start at an earlier time on the left side of the page, and you end on at a later time on the right side of the page, right? So in the act of reading English text, there's a correlation built into reading between side of space and time, right? Earlier left, later right, earlier left, later right. On every line of text, this correlation is built in, is reinforced. Okay. And of course, you get the exact opposite correlation when you're reading Arabic or Hebrew text, right? Progress through time corresponds to progress leftward across the page when you're reading Arabic. What about numbers? Does reading spatialize numbers? The answer here is no, right? Unless people are counting words or syllables as they go, there's no clear correlation between side of space and numbers. It's not the case that the bigger numbers tend to appear on the right side of the page and the smaller numbers tend to appear on the left. So given that reading spatializes time but doesn't spatialize numbers, we can make the following predictions, right? The correlations and experience principle has us ask, well, does reading spatialize time? Yes, it does, so it should affect the MTL. Right? Does reading spatialize number? No, it doesn't, so it shouldn't affect the MNL, the mental number line, right? By contrast, the common cause hypothesis simply asks, well, does it involve reading, writing, or scanning? Reading certainly qualifies. And so, according to this proposal, reading should affect both the MTL and MNL. Okay, so to find out which one it is, we had people come into the lab and had them read in English, either normally from left to right, as you are well aware, or mirror reversed from right to left. So just to give you a preview of what that's like, here's one of the many pages of text that they read. This is normal left to right orthography, and here's that same text mirror reversed from right to left. It's a little wonky at first, but after a few seconds or a few minutes, you get quite good at it. Okay, so they read like that for about half an hour, and then we gave them two analogous tests, one of their mental timeline and one of their mental number line. In the time task, participants saw month names like July appear on the screen, and one at a time. And they had to decide, they had to classify each month as either earlier or later than June, right? And they used lateralized response keys, one on the left, one on the right. In the number task, the test of the mental number line was the same, except they see numbers appear on the screen and have to classify them as bigger or smaller than 5 using lateralized response keys. And then, as is done in all of these tasks, what you do is you reverse the response mapping halfway through the trials. And of course, the order of these tasks was counterbalanced across participants. Okay, questions about procedure? Cool. Good. So let's look at the results. So we'll start with the time task. So here, participants were classifying months, right, as earlier or later. Remember that a negative slope here indexes a left to right mapping, right? So what this steep red slope shows is that participants who read normally, that's what red means, participants who read normally from left to right showed a strong mental timeline from left to right, whereas participants who spent about half an hour reading reversed text had reliably reduced mental timelines, right? And the difference between those effects is reliable. Cool. So reading affected people's mental timelines. Did it also affect their mental number lines, as everyone says it should? No. Right. So as you can see, those lines are not visually distinct, and they're also not statistically distinct. In fact, regardless of the way people read text, they showed normal left to right English mental number lines. Yeah.
Two quick questions. The first is, this doesn't necessarily need to be the case, but when you said that the number task was analogous, I saw that you were using 5 as the number, and then June is also the 5th month, so were all the months translated into their corresponding numbers?
Not exactly. Okay. So there's not, So actually the months were, let's see, February, April, March. It was basically June and the 4 months on either side. Okay. And for clarification, for the number task, although I only showed you the digits, we also ran the same thing but with number words. So the participants were reading the word 5, or the word 6, or the word 2.
And then my second question is, so I noticed the slope here between the rightward reading, like after reading it seems like, is there a more pronounced effect of that's making them steeper for the time versus the number? So like if you had run the time one right before they started reading and then right after, does reading actually prime them to have even more later in that moment? Or?
It's a good question, and I don't think we can know from these data, right? So I think what you're noticing is that this red slope is steeper than any of the other slopes. It could be the case. So if we just look here, we know that this is steeper than this. What we don't know is if training to reading normally strengthened participants' normal mental timeline, whether reading backwards weakened their normal mental timeline, or both. And the reason that I think we can't compare is just because they're different tasks, right? There's no reason to assume that participants' slope on this month task should be equivalent to their slope on this number task. So I think we can't know. But it's an interesting question whether you can strengthen people's mappings. I doubt that 30 minutes of sort of just reading strengthens it, since we do so much reading. But it may be more relevant for other types of training that are less common. Yeah. Other questions? Cool. Okay, so what does that mean? Right, so effective reading on the mental timeline, no effective reading on the mental number line, and a reliable difference of training effect on those two mappings. What that means is that reading training changed the mental timeline, but it didn't change the mental number line, even in the same participants. Okay. Cool. So here are these contrasting predictions, and our results clearly support the correlations and experience principle. But if reading doesn't shape the mental number line, as everyone thinks it does, then what does, right? What kind of experience can shape the mental number line? Well, what kind of experiences spatialize numbers? Lots of experiences, right? When we, in kindergarten walls, there are numbers spatialized explicitly on charts and graphs, on our computer keyboards and other cultural artifacts, and in finger counting, right? All of these things provide a correlation between numbers and side of space in a way that reading doesn't. So in principle, any of these things could affect people's mental number lines. For our purposes, I'm going to choose one of these as a test bed, finger counting, in part because some scholars have already proposed that finger counting may be influential on the mental number line, because it's handy, and because, most importantly, it spatializes numbers, right? When you count on your fingers, you start on one side at an earlier time, and you end on the other side. Sorry, you start on one side, you put all the small numbers on one side, and you put the big numbers on the other side, right? So everybody can take a minute to think about how they finger count, since I know that's what you want to do. Good, so that's the important feature, right, of finger counting for these purposes. So in experiment 2, we ask, can finger counting shape the mental number line? And to test this, we did a very similar experiment to experiment 1, except instead of having people read one way or another, we had them finger count one way or another. So we randomly assigned them to either count like this, from straight across from left to right, or straight across from right to left, right? Slower than that. It was very exciting training. They spent about 30 minutes counting on their fingers one way or the other. Yeah, question?
So when I finger count, I start with my right hand, because I'm right-handed, and then I go this way, but then I reverse it on the other hand. So I'm wondering if that's like a potential source of difficulty, or if I'm just anomalous that way.
I don't,
go like from one way to the other?
No, I don't think you're anomalous. I think, first of all, I think there's a lot of idiosyncrasy to finger counting habits. And I think it's not at all uncommon for people to count from thumb to pinky, starting on one side or the other, whereas we're sort of forcing people to count straight across. So the argument here is not that this is a naturalistic way of counting on your fingers. It's really a test bed, right? So the claim here is not, but if this all works out, the claim isn't, oh, the mental number line is all about finger counting, right? The claim is experiences that spatialize numbers are the kinds of experiences that can shape the mental number line. Finger counting, in the real world, finger counting may be one such experience. My guess is that it is, if it is one, it is not the dominant one, right? But it provides a convenient test bed for these claims. I think we could have done a similar experiment with, instead of counting fingers, counting coins on the desk, or right? And we would have made the exact same predictions, and I'm guessing found the same pattern of data.
Do you know if there's any correlation between handedness and where people start?
There's from what I have seen, there's actually no evidence of a correlation between handedness and. I mean, the thing is, for things like finger counting, unlike reading, there are all sorts of contextual constraints, right? Like if I have my water bottle in this hand and I want to count to 4, I'm probably not going to switch hands, right? Like, so I think that's one of the reasons why there's probably a lot of variation in people's finger counting habits. Okay, cool. So we gave people this very exciting task. And then gave them the same test of their mental number lines that participants in experiment 1 did, right? Where they're classifying numbers as either bigger or smaller than 5. Okay, so skeptical baby means before we look at the data, if you're as skeptical as this baby, you might say, okay, in experiment 1, you showed me that reading affected the mental timeline, but not the mental number line. Fine. But maybe the mental number line is just stubborn, right? Maybe reading didn't change the mental number line because the mental number line is just hard to change for whatever reason. That's reasonable. And if that's true, then finger counting also shouldn't work, right? It shouldn't matter if it's just the case that the mental number line is stubborn, then whether you're reading backwards or counting on your fingers backwards, people's mental number lines should be unchanged, right? But guess what? They were not unchanged, they were changed. Remember, so what this shows, right, in red, this is people counting this way. What those people show is a strong left to right mental number line, right? A mental number line that corresponds to the way they counted. Whereas participants who spent a few minutes counting from right to left showed reliably reduced mental number lines, right? So what we can do now is compare this effect of finger counting on the MNL to our null effect of reading on the MNL, right? And you can see right away this difference, right? And actually the statistics bear this out, that whereas reading didn't change the mental number line, finger counting did, right? Okay, cool. So let's interim summary here. So how's our common cause hypothesis doing so far? Not very well, right? It posits that the MTL and MNL should be changed by the same experiences, including reading, but that wasn't the case, and that both mappings should change in the same direction, and they didn't. Okay, so let's take a look at oh, right, okay. So the correlations and experience principle has so far predicted where we should find effects, right? We should find an effect there, and predicted where we shouldn't find an effect, right? Predicted correctly that reading shouldn't affect the MNL. Okay. But there's 2 things I want to point out here, that both of which we'll address in experiment 3. The first is that arguing from null effects is never the best, the strongest argument, right? We want to argue from positive effects, not from null findings. And the second thing is this box, right? So what happens over here, right? The question here is, does finger counting affect the MTL, right? Well, should it? We know already that finger counting spatializes numbers. Does finger counting also spatialize time? And the answer here, maybe surprisingly, is yes. Right? When you count on your fingers, you start at an earlier time on one side of space and you end at a later time on the other side of space, sort of like in reading. So in fact, finger counting spatializes both time and numbers. Okay, the trick though is that when you're counting up, like 1, 2, 3, 4, 5, these things go in the same direction. Time and number are sort of confounded, right? So if I'm counting like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the numbers get bigger that way, and time progresses that way, right? Because the direction of motion is the direction in which I'm spatializing time. So if both time and number are being spatialized to the right, we can't tell them apart. We can't tell apart the effects of time and number. Luckily, if you count down on your hands, like 10, 9, 8, 7, 6, then these things go in opposite directions, right? So when you count down, like this, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, what's happening is I'm spatializing time this way, because my motion is progressing this way, but the big numbers are that way, right? So time progresses this way, numbers advance or increase that way. So by having people count down on their fingers, we were able to evaluate the independent effects of time and number, the spatialization of time and number on participants' MTLs and MNLs in experiment 3. So I'll walk you through that in a bit more detail. So the question for experiment 3 is, can the MTL and MNL be changed by the same experience but in opposite directions? Okay, so in experiment 3 we had participants count down on their hands again. They were very excited to do this. Either the way that I showed you, to the left, or in the opposite direction, to the right. So notice that actually, regardless of which condition you're assigned to, you are the training that you're doing spatializes time one way and numbers the other way. Just a matter of which one goes which way. Cool. And then we gave them these tests of their mental timelines and mental number lines, auditory versions. So here's what we should predict. Before I show you the results, here's what we should predict. So the correlations and experience principle, right? To evaluate this, we should ask, well, does it spatialize time? Finger counting does, so it should affect the MTL. Finger counting also spatializes numbers, so it should also affect the MNL. And in fact, the common cause hypothesis also predicts positive effects in all quadrants, right? So what we have here is nothing is predicting a null effect. Both proposals are predicting positive effects. How do we tell them apart? We tell them apart by the directions of the effects, right? So let's start with common cause. The common cause hypothesis says that this training should have the same effect on your MTL as it does on your MNL, right? Because let's say you're counting down to the right, like this, 10, 9, 8, 7, 6, then that should affect both your mental timeline and mental number line that way. It should strengthen your normal mental timeline and your mental number line, right? That's what this account predicts. By contrast, the correlations and experience principle predicts that this training experience should have opposite effects on these two mappings, right? Because you're spatializing time that way, as the red arrow shows, it should shift your mental timeline that way. And because the numbers get bigger this way, it should shift your mental number line in the opposite direction, right, to the left. Is that clear? Cool. So that's for that training condition. And of course, in the other training condition where people are counting down the other way, all of these arrows reverse, and you still have this predicting same, correlations and experience predicting opposite effects on your mental timeline and mental number line. Okay, so what do we find? we find opposite effects on the mental timeline and mental number line. So let's start with time again. So here in red, what these participants spatialize time this way across their hands, and they show the stronger left to right mental timeline, whereas participants who spatialize time to the left show reliably reduced mental timelines. In fact, this mental timeline doesn't differ significantly from 0. So what that means is that the way participants were spatializing time across their fingers during training shaped their mental timeline despite the way they were spatializing numbers. Okay. Here's the number data. So the first thing to notice here is that the pattern is the opposite, right? Is that whereas here the red line is the steeper line, here the blue line is the steeper line, right? So what that means is that participants who put the big numbers on the right and the small numbers on the left, right? Big numbers on the right showed the stronger mental number line, and participants who put the big numbers on the left showed a weaker mental number line, despite the way they were spatializing time. Right? So to summarize this pattern of data, what this shows is that finger counting training changed the MTL and the MNL in opposite directions. Right? Cool. Okay, so that's the data. Let's return to our initial question: how does culture shape concepts of time and number? Well, for a long time, people have assumed the common cause hypothesis, which, as I argued, wasn't well supported by the data to start with, and certainly isn't supported by these tests that I just showed you. So what I would argue is that it's time to say goodbye to the common cause hypothesis. There is no common cause, but there may be a common principle that dictates how different mappings in our minds are sensitive to different aspects of our experience, right? The correlations and experience principle gives us that. So what have we learned about what experiences shape the mental timeline and which ones shape the mental number line, right? What I've shown you is that reading text does shape the mental timeline, but is that it? Is that the only experience that does that? No, almost certainly not. It may be likely a very important one. But what I've shown you is that it's not specific to reading, that other experiences can have a reliable effect on the mental timeline, like finger counting. And I'm sure others as well. Anything that spatializes time, in principle, should affect the mental timeline in some small way. What about the experiences that spatialize, that affect the mental number line? Well, finger counting is one of them. But is that the only one? I would argue almost certainly not. As I told you earlier, lots of experiences spatialize numbers. We talked about finger counting, but in another experiment, some researchers looked at written number lines, right? How you see numbers spatialized on a page. And they did this very clever experiment where they gave people recipes where there were numbers embedded in the recipes. Right, and it was either the case that the small numbers were on the left and the big were on the right, or the opposite, right? Big numbers on the left and small on the right. The first would be very salty eggs, but I'm not going to argue with that. I think I made that up. Right, but what this does is it gets at your question from earlier, Michael. That what about reading numbers? Right, like maybe, okay, so we've sort of ruled out the fact that reading and writing per se matter, but the way numbers are spatialized in text, on keyboards or wherever, should matter, not just on your fingers, but on the page. And that's exactly what they find, that the way you see the numbers spatialized in this text reliably shifts your mental number line in the way you'd expect. So we can add to this list of things that shapes the mental number line, reading and writing numbers. Yeah.
You can punt on this for later, but
yeah.
It sort of connects to what you were just saying. I realized my example, like 789 earlier, was kind of the opposite of what I was trying to say at that point, which was, even though you're reading 789 from left to right, it's actually like a countdown in terms of the first digit being the largest place value. hundreds, tens. So I wonder if you ran an experiment where you trained people to read very long numbers, like 114 quadrillion, 792 billion, all of that.
Yeah.
It's kind of like a countdown, right? Where you're,
Interesting.
Do you think that might modulate people's number line?
It's a good question. So I think what you're pointing out is that in addition to the actual sort of magnitude of the digit itself, that in multi-digit numbers, it's the tens place or the hundreds place or the thousands place, and so if we interpret 1,200 as like 1200 as 1,000, the first place represents 1,000, and this the two only represents hundreds, then maybe it should have this sort of like inverse effect on the mental number line. That's plausible. I sort of doubt that that's how people interpret multi-digit numbers, but I could be wrong.
1000 could be smaller or something. 999, like 1,000, because it's like little numbers. It's like it's a 1, 3 zeros.
Oh, that too. Right. Yeah. There's a lot of ways you could think that multi-digit numbers have an effect. There's sort of a neat feature of multi-digit numbers. It's called Benford's law, and it shows that in like numbers that people actually encounter, you're like much more, the first digit in a multi-digit number tends to be small. That like you encounter bigger numbers on the right side of a multi-digit number more than on the left. So sort of built into multi-digit numbers in our experience is a correlation between big digits in right and small digits in left. That would be undermined by this sort of like interpretation that you're suggesting, but it's an open question.
Perhaps that's the reason why $5.99 is an excellent price.
It is an excellent price. Yeah, I'll take 2. Yeah. Good. So my just to reiterate from before, my claim here is not that the mental number line is all about finger counting, just that finger counting is one example of a family of experiences that spatialize numbers that can shape the MNL, and that reading is not one of them. Okay, so to back out a little bit, we started with this question: how do people reason about abstract ideas? One of the ways is with mental metaphors, and to the extent that people use mental metaphors, the correlations and experience principle can help us understand how the mappings in our minds are shaped by our experiences in the world. So I want to thank you for your attention and thank my PhD advisor and former lab. And I'm curious to hear your thoughts and questions. Yeah.
So I feel like there's a little bit of a chicken and the egg problem here, and I'm curious your thoughts about it. So we're talking about a keyboard and kids counting in a classroom, but those tools came from human minds to begin with. So as you're saying, how kids are learning on a number line in school, but that's because somebody said, oh, you should use a number line to teach because maybe that's how we're representing numbers, and so then that's being reinforced. So I'm curious about, like, where did that even come from in the first place, mapping left to right or even right to left? Like, why not up and down, for example?
Yeah.
And in addition to that, when you're talking about these experiences that we have, but those experiences are still coming from somewhere. So why, would you have any idea of like where those experiences were built on?
Yeah, no, I think it's an interesting question, and I think largely an anthropological question, right? That like, I don't know why we, in some cultures, the numbers and the text go the same way, and in some cultures they go opposite ways, or why it is that Hebrew goes from right to left, whereas English goes from left to right. I think you're right. I think it is a little bit of a chicken and egg question, right? And probably like subject to all sorts of like idiosyncratic historical accidents that I would only be guessing at, right? Maybe the anthropologist in the room knows.
It's to do with a body counting system. So they don't count their fingers, but they count on 27 parts of the body. It starts on the finger and goes up through the head, then down to the other side. I think even within that culture, some people start on the right-hand side and some people start on the left-hand side. So even within that, there was no sort of right way to do it. It's just down to people's personal preference.
Yeah. I would, to throw something out there about writing direction as a, I imagine that it probably depends on the way in which the medium in which you're writing. That, if you're writing in a way, with ink, for example, and most people are right-handers, then writing this way is going to cause a lot of smudges and writing this way isn't. Whether that played any causal role in the development or evolution of English, I have no idea.
But it seems right that some sort of material, something out in the world that's repeated, would feed into people and, okay, yeah, it goes from left to right, or whatever the case may be, wherever it started. But when you don't have that informational input, if people, it's just a oral tradition, probably get more diversity.
Yeah, right, yeah. Yeah.
I don't know whether it was your dissertation, but when this paved the way towards, let's talk about left and right. I mean, the spatializing was at least two-dimensional there.
Sure.
Going up and down, obviously, again, writing up. I mean, that's even harder. You could, if you were left-handed, you could not smudge, but
right,
it's
right.
harder to write down the direction. Do you have any predictions for up and down? Are there similar problems like the one you identified? Inconsistent effects across domains.
I think, so there have been studies of vertical mental timelines and mental number lines. The findings for the mental timeline seem pretty clear cut in my mind that, in English, in addition to writing and in most languages, most orthographies that I'm aware of, we, in addition to writing from left to right on a line, we progress down the page, right? And so, given that, the correlations and experience principle would predict that we should have a top to bottom mental timeline, that our vertical mental timeline should go down, and it does in Westerners.
It does. I mean, higher values are.
Value is different, right? Value and temporal sequence are different. So we do also have mappings of many other domains, including sort of value, quantity, like price, right? Prices go up in language, but that's different than a temporal sequence, right? For the number case, it's trickier actually, I think, because we see it sort of depends what we're mapping, I think. So, you might argue that big numbers should go up. Bigger is up. Why would that be? Where would we learn that in experience? Well, from piles of stuff, right? When you add another thing to a pile, it tends to go up. It very rarely goes down, right? So maybe that gives us this experience that teaches us that more is up. On the other hand, if you're making a list, right, then the first thing goes at the top and the second thing goes under it and the third thing, right? So the bigger numbers go down. And actually, if you look at the vertical mental number line literature, it's mixed. Yeah, Tori.
I have more of a couple of musings, I think, than questions. One of them is inspired by Gene's thinking. I'm thinking of the piano. Mm-hmm. And I'm just wondering if you would do a truly cruel experiment where you give, I know, you see where I'm going, give pianists the reversed keyboard. Ouch.
Yeah.
Do you think you could affect their, what would it be called, their pitch line?
Yeah, I think you probably would. My guess is that, if you play the piano, you implicitly associate higher pitches with the right, and if you play other instruments that have different mappings of pitch on the instrument, that you mentally spatialize pitches differently.
So, which brings us to the second musing, to do with the cello.
Yeah.
The double bass, where there's interesting, maybe called semantic dissociation between our use of the word of the words up and down, whether we're speaking about pitch per se or the production of pitch. Because I could say, play a higher note, play higher note, go higher note, no, higher note.
Yeah.
Right. Or I could say play lower down. So it really
That's tricky.
depends on what you are specifically referring to.
How do cellists talk about it? Do they talk about it in terms of pitch or in terms of space?
It depends on the context.
Really?
About technique or music, I guess.
Huh, that's interesting, yeah.
Similar with the guitar, like you go down the guitar, but you get to the high-pitched strings, and then it's like you're going up in pitch, but you're going down
in space, right.
And it's the opposite for the violin. Because you go up and it's higher, when you play lower down, it's lower.
Yeah. Maybe we should test a bunch of musicians. Yeah, totally.
Okay. Something that was really striking here is how flexible people's mental number lines are. And that actually surprised me. We read, and some people think about numbers all the time, so the fact that just, a relatively quick intervention can swap or even have any effect, I found that pretty surprising. I'm wondering if you can comment a bit on maybe any developmental implications, like Siegler and Romani show teaching kids on a game, on a number line, that like only a certain kind of board works, and only when the kids are actually counting one. So it's to help kids with their whole number knowledge. And so they have this board, and the kids count 1, 2, 3, 4, and only in that case do they really show a lot of benefits for number comparison between being able to compare these whole numbers. Just moving the pieces or only counting with no board doesn't work. And then showing if they have like a circular board or other shapes also don't work. So it's this left to right. I don't know if they tried it in the reverse direction, so I'm actually curious now to see if they did that. But I'm just curious, like, why you would think that might help, because you could still argue that counting in a circle, you still have that space mapping, although it's in linear space.
Right.
But there's no effect of their whole number knowledge. So I'm curious how that kind of thing might fit in with some of the things that you're thinking about.
Yeah. Yeah. So I think for the second question, I think so there's a few reasons why lines might be better than circles, for example. One is that there's some proposals that even extremely young infants, there's some evidence that some even very newborn infants map numbers onto left-right space. So there's clearly more to it than that because it varies across cultures. But there could be something sort of innate about linear mappings. The other thing is just that circles have this problem of repeating, and that could be helpful, or you could imagine that having to sort of remap 5 things on a circle or 10 things on a circle might be trickier spatially than on a line that continues forever, right? I mean, in a way, it's sort of like, what's easier to represent 1 dimension or 2 dimensions, right? So those are some reasons why a line might be more effective. But yeah, as for your first question, the flexibility. So right, it's surprising how flexible these things are. And I think there's a few things I could say about that. I guess what I'll say is, I think part of what first of all, the thing I would say is, these data, this sort of flexibility has been shown before, has been shown in other domains. So it's not just a feature of the mental timeline and mental number line. In other mappings of pitch and of emotional valence and other things, there's this like remarkable flexibility in the mappings. One of the things that I think tells us is that we have this sort of illusion that these concepts, right, the way we think about time, are stable features of our minds, right? That they're constant things that are sitting in our heads. When in fact, what these findings suggest is that the stability isn't in our heads, the stability is in the world, the stability is in our experience, right? And that if you tweak the right aspect of people's experience, what you find is that actually you very quickly disrupt the way, or change the way that people think. And so, the implication is we're sort of much more in tune and tuned by the experiences that we're having, but it feels stable. It feels like a feature of our mind because we just don't change our environments in that much or in the right way. We don't ever read from right to left. So we don't see these changes.
Although we change it so much in a particular direction, always the same, always goes from left to right or whatever. And that, because I was just thinking with the looks up, and the body counting, you don't see that regularities as you get left. You go from left to right as you like, because there's less sort of.
There's no constraint.
There's nothing pushing you to go in that either or direction.
Yeah, and it's not clear that you would even, if you, let's say we did read, let's say you did finger count, you finger counted in all kinds of different ways, and that it changed your mental number, for whatever reason, your mental number line changed directions a lot. I'm not sure you would know. I'm not sure why you would know, right? Like these things are, I think we're sort of blind to them.
That kind of leads me to my next question, Michael, which is that, so then are there some cases that it's more beneficial to reverse your timeline, your number line, your mental timeline, or to have it in the vertical direction, for example, for like some kind of like problem that you need to solve that you could actually teach people to like flexibly select between, like basically like if people know like, wow, you can use all these different representations of time, can they flexibly select between them, or do you think that this is a more like implicit thing that just happens kind of under the hood?
Yeah, it's a good question. I think it's an empirical question. My guess is that having, on a given axis, having a reliable mapping is best. That like, we use the reason that we have these mental metaphors, right, that we use space at all to think about numbers or time, is presumably because it helps, right? Because it's like a heuristic for thinking about something that's hard to think about. And so having too mushy or flexible a mapping at any one time seems like it would make it less useful. That said, well, yeah, that's one point. Another point is I think these axes probably don't interfere with each other. I think being trained on left to right, counting or reading probably has little or no bearing on your vertical mappings of time and number, and your sagittal mappings of time and number, all of which might have different experiential bases and sort of are shaped by independent forces, right? So I think it's possible that actually people can have a strong lateral mental number line, a strong vertical mental number line at the same time, and use them as needed. Use the preferred axis as needed. Yeah, Michael.
So there's kind of an asymmetry between numbers and reading if you think about it, because and I once published a paper in Memory and Cognition looked at like perception of algebra strings. It's sort of a riff of perception of words, and we spend all this time when we're learning to read decoding from left to right. And so within a word, there's this sort of left to right aspect, and then there's the between word, and then between sentence and down the page sort of thing. Whereas you almost never do that with numbers unless you're reading the latest, largest prime number. You're not going to be reading left to right and then down the page. And at that point, you've lost all the semantics of what place value you're in. You just know it's like some 879-digit number. And you're not saying quadrillions in your head or anything like that. So
except in algebra, maybe. It was that.
Well, algebra is a little bit different, and it sort of relates to other sort of not left to right sort of things. So like if you look at ideograms, like Chinese characters, kanji, sometimes they're compositional. So like a forest is a set of trees, right? Yeah. It's not like a left to right sort of reading within the word.
Sure.
And so you might find something different that's going on there across languages that use ideograms versus left to right decoding or right to left decoding for Arabic or Israeli. And I think what it means is we don't have much practice going in one direction or the other when we're looking at numerals, because they're usually relatively small. It's rare that we'll have to read out a 12-digit number or something like that. Yeah. Whereas even within words, there's left to right kind of character, and then between words, there's left to right. Yeah. So you can imagine how the word aspects might be maybe more malleable in some respects, in spite of like the reversing snark kind of thing.
That the word would be more malleable? That which would be more malleable?
That our number line
would be more malleable. Right.
Since we don't have all this time spent going left to right within word between words and so forth.
Right, yeah. It does seem like for time, especially in cultures that read a lot, that there's just this one very clear directional correlation between space and time, that like later is to the right if you read, and if you spend a few hours a day reading, right? Whereas I agree, for numbers it seems less, it's less clear that there's like one overwhelming single experience.
Those sort of very large numbers as well, you probably wouldn't even beyond sort of ability to read. Yeah.
Right, which is where like written number lines come in. So if you look at graphs, right, you don't have to, you're not looking at a multi-digit number, you're looking at a 1 on the left and a, you know, and then bigger numbers on the right. Or if you count on your fingers, right, like these there are, or you use a ruler, or right, there are a variety of things that besides multi-digit numbers that provide this correlation.
The algebra is a little bit like an ideogram in that, well, like 3x, y, z, it's like a noun phrase, you know, so it's compositional. But if it's, you know, 7x, y, z plus 14, then it's kind of the order doesn't matter. You can flip the order back and forth. Whereas in sentences, you know, it matters a lot if Kate is kissing Mike or vice versa. So there's interesting sort of micro and macro compositional aspects that probably play out, although, you know, people don't spend much time doing algebra, so, you know, didn't find much effect in there compared to numbers.
Yeah, I don't know if I'm prepared to subject people to lots of algebra reading.
Yeah. Experiment that has the rubber tummy pattern.
Yeah. But this way or this way.
There's an awful lot of Lakoff in this, and it's that's Chicago, and you're doing it here, and I feel like there's never been like enough research on those ideas. Is there more stuff out there?
On the sort of like mental metaphor world.
What's the metaphor?
Yeah. I think, I mean, so I, you know, a lot of this is the thinking of that guy. Daniel Casasanto has looked at a bunch of, like, the term mental metaphor I took from him, and he's looked at the origins, he's looked at mental metaphors besides these two. You know, space. There's a mental metaphor linking left-right space and emotional valence, for example, meaning good or bad, basically. Showing, and what he shows is that the right side of space people associate with good, and the left they associate with bad, but only if they're right-handers. And if you're a left-hander, the experience of being a left-hander, because you have a more fluent experience interacting with stuff on the left side, you implicitly associate good stuff with the left side, whereas right-handers associate with the right. Anyway, there's a variety of conceptual domains in which these sorts of experiments have been done, showing, and basically what I think, where I think this sort of expands and differs from the Lakoff and Johnson stuff, is in the relationship to language. So whereas sort of traditionally conceptual metaphors have been sort of like looked for and found in language, the sorts of mental metaphors I'm talking about here are real ways that our minds, that our concepts are structured, right? They're real conceptual structures. But in this case, don't actually show up in language at all, right? Which is where we started. We just don't talk about time or number in this way, and yet we think about them in that way. And there are other examples. So that's an example of how you can have metaphorical thinking that just is absent from metaphorical language. And so that's one relationship between metaphorical thinking and metaphorical language. And there are others, right? There are some ways of metaphorical thinking come from language, that like the way we talk about it causes us to think about it that way. There's evidence that there are ways that we talk about, there are metaphors in language that actually contradict the way that we think about those domains, and so forth. So I think the sort of state of research in metaphor theory is exploring that. Is like, okay, so we started with this idea that that we talk and think metaphorically, but actually what what is the relationship between the way that we talk metaphorically and the way that we think metaphorically, and it turns out to be complex.
Yeah, the dynamism of the, I think like I was going to say, well, this is the way
Yeah.
it is, and your body works this way, therefore it's always the same.
Yeah.
You've shown that it's extremely malleable.
Right, yeah, right, yeah. Other questions? Thoughts? Well, thanks for coming. Thanks for your attention.
Thank you very much.
Yeah, thanks for having me.